Okay, well, it is good to see everybody. I hope that you had a great weekend. We're looking at our first full week. 2 weeks, we have our first 3-day weekend, so always something to look forward to. So, a couple of things I want to go ahead and again bring to your attention. First, let's start with the expectations. Okay, you folks have been doing a great job on this. I'd say continue to keep it up. Be on time. Grab any materials provided from the front bookshelf. The calculators are out today, so if you didn't grab one, we'll definitely need one of those probably at some point. Be in your seat and ready to go when the bell rings. You folks have been following directions. Can't thank you enough. You're doing great. We will hopefully stop maybe more than 5 minutes early to go ahead and get the calculators back up there. But again, we have that new policy. In fact, it's a state law. No cell phones, smartwatches, all that good stuff. We got to have that put away. So are there any questions on this? Okay, let me go ahead and show you our website. All right. We are now the week of the 18th to the 22nd, so I don't think it's going to allow me to pull this up simply because, again, of that glitch that I was telling you about, whatever the problem is. Thank you, Enrique. But you have a digital copy of everything that I'm going to hand out to you in here. So everything is here. Are there any questions about the website? Okay. In fact, if you take a look at our previous week, okay, if you go ahead and click on one of these video links right here, it tells you exactly what we were doing that day. Those numbers at the end, that's the what? What's that 8/14/25 right there? That's the date. So you know exactly on which day that recording was made. You can match that up to whatever day or days you were absent. But I encourage you, even if you're not absent, probably not a bad idea once or twice a week, get in the habit of looking at the website just to make sure you're still up to speed in case you happen to miss anything that I go ahead and bring up. Okay, just a couple more housekeeping items and then we'll be good to go. Let me go ahead and take care of the folks. So Emma, you weren't ATC, you were Agriston. That's right, okay. And Josue, you were ATC? Okay. Okay, so I got all you folks here. Now we have perfect attendance. Fantastic. Okay, so part of our housekeeping items, I want to go ahead and let you know if we have a drill in a particular week. We have our first drill this week. On Friday, near the end of 7th period, we're going to have our first fire drill. Okay, so be thinking about where your 7th period class is, what side of the building you're going to be exiting on. But let's say there's a fire drill, or heaven forbid, knock on wood, real fire during 5th period. Where are we going to go? First thing, you're going to leave all your belongings here because they can be replaced. You cannot. We're going to go out the door, right down the stairs, and everybody knows right below us is the nurse's office, right? So when you get to the bottom of the stairs, go past the nurse's office, out the door to the sidewalk on 19th Street. Okay, when you get to the sidewalk, then you're going to head over to the east parking lot. That's where the band practices after school. Okay. Now, this is super, super, super important. When you get there, what do you want to do? What? There we go. Because I need to go ahead and make sure that everybody got out of the building safely. So I've got to take a roll on Crisis Go. So definitely come find me. I'll probably be over there like, where are you? You know, I know you want to talk to your friends. That's okay. Just come find me. Make sure I've got you. Okay. And as far as this week goes, if you're looking at the website, today and tomorrow, we're going to be looking at exponents and radicals. We'll have time on Wednesday to look over the assignment. We'll answer questions on the assignment this coming Thursday, and then we'll finish up our week with a quiz on Friday. Okay, so it should be pretty easy. Now, I do want to give you a heads up. You're still with me in here next week. But starting on Monday of next week, each day you come in, you're going to be taking a different module. We're going to take a fully released PSAT exam. So we're going to take Monday and Tuesday for English, Wednesday, Thursday for math. Make sure to bring your charged Chromebooks. We're going to go through the whole thing. Okay, so that's coming up next week. The fact that we're only a couple weeks in, do not let that bother you. Mr. West got you. So I know that is a lot of information coming your way on a Monday afternoon, but are there any questions? Okay, well, let's say we go ahead and get to some math. All right, exponents and radicals. So here are the laws of the exponents that we want to be familiar with. And then it gives you an example for each one of these. Okay, so anything to the first is that value. Anything to the 0 power, a lot of people typically tend to mess up on this one in the beginning, but anything to the 0 power is 1. Okay, if I'm going to multiply terms that have the same base, x to the m times x to the n, we keep the base, we add the powers. Okay, so when you're working with these exponents here, you're going to be doing, one of 3 things. You're either going to be adding, subtracting, or multiplying those powers together. If you have a fraction, you got division, x to the m divided by x to the n, you keep the base. This is where you're going to subtract those powers. I kind of like to think of it fraction, subtraction. Just an easy way for me to kind of remember that, Like I'm a poet and I didn't know it. You want the best, come to the West. Word. I'm low-key fire. Is that right? Did I say that right? Start rapping? Oh, I don't know if you want me to do that. Okay, yeah. Maybe later. All right, so let's say I have x to the m in parentheses, a power raised to an additional power. This is when you're going to multiply those powers together. Okay, now this next one is just an extension of the power to a power. You'll distribute that outside power, but you only multiply a power times a power. You will never, never, never multiply a power times a base. Okay. Here we have the quotient raised to a power, x to the, divided by y to the m power. So I just, again, go ahead and distribute that power to every term inside. So x to the m over y to the m. And then this one here is a super important one. We always say we're not completely simplified until there are no negative powers. Okay. Well, if you have a negative power, you're going to take its reciprocal. Okay, so let me show this a little bigger. So if I have x to the negative m over 1, what does it mean to take the reciprocal? What do I do with the numerator and the denominator? I flip them. So if I'm going to flip this, this now becomes 1 over x to the positive m. Once you take the reciprocal of a negative power, then it's going to become positive. Okay. Now, even if this were to show up in the denominator, if I had something like 1 over y to the negative n, even if it starts in the denominator, I'm still going to take the reciprocal. So when I go ahead and flip this, this is now y to the power of n over 1. But what happens if you divide something by 1? It stays the same. So this is just y to the n power. Okay. All right, so we're going to go ahead and kind of build up to the problems we have in our notes today. So exercise, we want to evaluate these without a calculator. Now, this is super important because this is going to help you understand the difference between if I have a negative base with parentheses or without parentheses. And we can even put these in the calculator if you would like. But let's start with these. Can anybody tell me what's a negative 2 cubed if the negative is included? Positive what? Well, let's think about it. What does it actually mean to cube something? Yeah, whatever that power is, you're going to take the base and you're going to multiply it by itself that many times. So when I have negative 2 cubed, this means negative 2 times negative 2 times negative 2. So let's see, if I have a negative times a negative times a negative, that's still a negative. Okay, well, what's 2 times 2 times 2? 8. Okay. Now, let's take a look at something else real fast, because a lot of these go off the same idea. What if I were to just have 2 cubed? What's that? 2 times 2 times 2, well, that's 8, right? What about a negative 2 to the 4th? Is it still going to be negative or is it going to be positive? This one's going to be positive. So if I were to go ahead and say negative 2, negative 2, negative 2, negative 2, okay, 2 negatives is a positive, so positive 16. That's one of the things you want to be on the lookout for. If you've got a negative base, if it's odd, that means your result's going to be negative. Okay? If you've got a negative base with an even power, it's going to turn out to be positive. Now, this what I'm about to say, it looks like it's going to break that rule. Now take a look at the one right next to it. This one right here. Negative 2 cubed. Okay. What do you think that answer is? The same? So what's that same answer? Is it negative or positive? Negative 2 cubed? It's 8. Okay. All right. So that really didn't seem to be that big of a problem, right? Okay. Well, let me go back and revisit one of these here. We know that negative 2 to the 4th. Okay, parentheses, negative 2 to the 4th. That was going to give me a positive 16, right? What if I drop the parentheses? What's my answer? Is it still positive 16? Aaliyah? It's going to be negative. Because the order of operations are what you want to follow here. What am I talking about when I say order of operations? Or if I were to say, please excuse my dear Aunt Sally. What's that P stand for? Parentheses, excuse, exponents. So in this case right here, if I were to go ahead and plug these in the calculator, these are the results it's going to give me. In fact, let me go ahead and do that. I'm going to show you. So if I were to go ahead and take parentheses, negative 2 to the power of, and if I want to put any power in there, we call this the caret button. It's like just the top of the house on the far left. So I want to go ahead and put in 4. See, that's going to give me a positive 16, but if I go ahead and put in negative 2 to the power of 4 with no parentheses, it gives me negative. Okay, because the calculator is programmed to go through order of operations, just like you were taught a long time ago. So it doesn't see this as a negative 2. It sees that as a negative 1 times 2 to the 4th. So it takes care of the exponent, and then it multiplies. So a really good way to kind of get around this, especially if you're using the calculator, every time you substitute in, always go ahead and put parentheses. That way you'll never run into this problem right here. Okay. Well, we're not going to do all of these, but we're going to go ahead and run through enough that hopefully people feel, comfortable with them. So let's start with number 1. I need parentheses negative 1 to the 4th. So is that a positive 1 or a negative 1? That's a positive 1. It has an even power. What about parentheses negative 1 to the 5th? That's a negative 1. Why is that one negative but the other was positive? There you go. This had an even power. This one had an odd power. Okay. What about negative 1 parentheses to the 10th? Or not 10. Because 1 to any power is still going to be 1, right? But is this one going to be positive or negative? Positive, because it's an even power. Okay, so Sebastian, help me out with the next one. What about parentheses negative 1 to the 15th? Negative what? Negative 1. There you go. There you go. Fantastic. Okay. Let's go ahead and kind of start to skip around. What about number 6? Negative 1 to the 8th. Would that be a positive 1 or a negative 1? That would be a negative 1. Because the one right before it, if the negative is included with the parentheses, that's how it becomes positive. See, this is that scenario that I was just talking about. Okay. Even though it's even, it's not contained within parentheses, so it's going to give me a negative. Okay. What do you think about number 7? Now, forget about this negative right here. Just pretend it doesn't exist. So what's negative 1 parentheses to the 8th power? That's just positive 1, right? But now, we're going to go ahead and add that negative that was on the outside. So there's a negative 1. Okay. All right. What about number 8? Negative 3 in parentheses cubed. That's a negative 27. Much the same token, number 9, even without the parentheses, that's still a negative 27. Because 3 cubed times the negative 1. That's how your calculator would interpret that. Okay. Let's skip to number 12. The negative of negative 4 cubed. Okay. Well, let's do the same thing. Let's forget about this negative right now. Okay, pretend it doesn't exist. I need negative 4 cubed. So just think about what's 4 times 4 times 4. Oh, a little high. 64. So is this a positive or a negative 64? Because remember, we've got a negative times a negative times a negative. So that is going to be negative 64. There's negative 4 cubed. And then now I'm going to apply that negative that's on the outside. And we know a negative times a negative is what? So that would be 64. Okay. Let's get to one of these operations here. Okay, how about number 14? I've got negative 1 in parentheses to the 4th times 3 cubed times 2 squared. Okay, and if you want, we can take care of each one of these one at a time. Okay, what's negative 1 in parentheses to the 4th? So that's 1. It's in parentheses with an even, so that's positive. Okay, Bella, what about 3 cubed? So 3 times 3 times 3. And it's okay if you don't know, you got your calculator there. You can use it as well. Nothing wrong with that. Seven times, and then I need 2 squared. Well, we know that's 4. So what's 1 times 27 times 4? Okay, 108. Here we go, positive 108. Okay. What about number 16? What's 3 to the 0 power? 1. Anything to the 0 power is going to be 1. I could have 1 billion to the 0 power. That's still 1. Okay, power of 0, the value is 1. What happens on number 17? What happens if we have a negative exponent? What's that key word? We have to take the what? We have to take the reciprocal. Okay, so I'm going to write reciprocal. So I'm going to put it over 1. So what's the reciprocal? 1 over 6, now to the positive 1. So this one, you don't have to put the 1. I just want to go ahead and emphasize that it's not positive. So yeah, your answer is 1/6. Okay, fantastic. Okay, let's see what else we got. If I can take this out of here. Okay, what about 5 to the 0? That's 1. 3 squared? Okay, that's 9. What about 3 to the negative 2? Again, I want to take the what? The reciprocal. So when I flip it, this is now 1 over 3 squared. So it's what? 1/9. There we go. That's how we deal with a negative power. We take the reciprocal. So somebody help me. What's 5 cubed? 5 times 5 times 5. Close what? 125. So this is 125. So give me the final answer. What's 5 to the negative 3? Remember, we're taking the what again? So what's my fractional answer? 1 over 125. That's a 2 right there. I can write that better. 2, 2, 2, 2, 2. Okay. Okay. Cool, cool, cool. Are we starting to see the idea? Anybody lost? Are there any on there that I skipped? We're like, I want to go back and work those together. Fantastic. Okay. Well, let's move on. Let's go ahead and start getting a little bigger. Simplify so that your answer contains only positive exponents. Now, coefficients are okay. We don't want to confuse a coefficient with a power. Don't use a calculator. The first 2 have been done for you. Answers are going to be, well, we got the answers. We'll get those ourselves. So let's see. Number one, it already did for me. It says 3x squared times 2x cubed, and we got 6x to the fifth. How'd they get that? Yeah. So first we multiplied the coefficient, so 3 times 2, that's what gave me the 6. But now, if we multiply terms that have the same base, what do we do with the powers? We add them. Remember, with the powers, we're either going to add, subtract, or multiply depending on the circumstance. Okay. Well, let's take a look at number 2. I've got 2k to the negative 4 times 4k squared. Now, here's the thing. A lot of students, when they immediately see that negative power, you immediately want to go ahead and take the reciprocal. You're more than welcome to do that, but you don't have to. There's another rule that I could apply. Let's take 2k to the negative 4 times 4k squared. Let's just multiply it out as it is. Okay. So what's 2 times 4? 8. So now I want to multiply k to the negative 4 times k squared. I'm multiplying with the same base, so this other rule can still apply. I can say k to the negative 4 plus 2. What's negative 4 plus 2? Okay. Would that be negative 2? Now, here's the thing. Have you ever heard that old phrase, if it's not broke, don't fix it? Yeah. So you only have to take the reciprocal of a term that has a negative power. Like here, I don't want to touch the 8 because, see, it's already got a positive exponent. So I'm going to leave him exactly where he is. So think about it like this. We do take the reciprocal, but basically all it's doing is changing levels. If it's in the numerator, the negative power wants to go where? It wants to go down. So see, the 8 would stay up top. Down below, that's where the 2 would be positive. That's how they got that expression. Can I talk to that? Okay. Now, even if I had taken the reciprocal immediately, I still would have been able to get the same answer. Does anybody want me to show you that? Oh, sorry, you want to see it? Okay, let's do it. So let's say I took that reciprocal immediately. So 2k to the negative 4, would everybody agree that's now 2 over k to the 4th times 4k squared? Now, if you're in a situation like this where you have an actual fraction and you're going to multiply it by just some monomial, just pretend it's over 1 and then just multiply straight across. What's 2 times 4k squared? There's 8k squared over k to the 4th times 1. That's k to the 4th. Now, see, we've got the same base in the numerator and denominator, so we could go ahead and use that quotient rule where we subtract. Remember fraction, subtraction? I don't actually really like to use that rule. I kind of tend to think about it like this. Okay, if I were to expand this, how many k's are in k squared? So I have 8 times k, right? How many k's in k to the 4th? There's 4 of them. K times k times k times k. Everybody okay with that? I couldn't resist. But see, if you just look at it this way, you can cancel out pairs. Okay, so you see how I have 2k's left? 2k's above will cancel with 2 below. I still get 8 over k squared. So the thing about these exponent rules, there's no specific order that you have to use them. I can go in any order that I want. Okay, so let's start looking at some of these. Okay, if this will erase. Haha. Okay, so let's look at number 3. I've got 5x to the 4th times 3x to the negative 2. Okay, somebody give me an idea. What exponent rule can I use? You want to take the reciprocal? Let's do it. So I'm going to go ahead and say 5x to the 4th times, remember, I only have to take the reciprocal of the one that has the negative power. So that 3 is staying up top. Down below, this is now an x to the positive 2. We just saw a scenario like this. If we're going to multiply a single term by a fraction, just put it over 1. Okay. What's 5x to the fourth times 3? That's 15x to the fourth. Perfect. 1 times x squared is an x squared. Now let's just do exactly what we did a moment ago. 4x is up top, 2 below. I can cancel 2 below with 2 above. My final answer is 15x squared. Now, Emma. Okay, cool. Had the first idea to go ahead and use the reciprocal. Fantastic idea, because it got me exactly what I wanted. Let me show you this. What if I had just multiplied? What's 5 times 3? 15. If I multiply terms that have the same base, what do I do with those powers? So x, what's 4 plus a negative 2? It doesn't matter in what order you go through those rules. It's always going to end up the same. It's kind of like a game. Those are the rules. You follow the rules, you're always going to get to where you need to be. Okay. So let's go ahead and start to skip around a little bit. Let's go to 6. It says negative 3, a squared b to the negative 3 times 3a to the negative 5b to the 8th. Okay. What would you like me to do? What exponent rule leaps to mind? Emma, you got one? Just multiply? Okay. So let's see, what would I multiply this negative 3 by? 3. Negative 3 times 3, that's going to be a negative 9, right? Okay. So now I'm going to multiply a squared times a to the negative 5. We're multiplying with the same base. So we'll like add, subtract, or multiply those powers. We're going to add. What's a 2 plus a negative 5? So this would be a to the negative 3. And then now I want to take b to the negative 3 times b to the 8th. Same rule, so b to the what? B to the 5th. Is everybody okay with how I got that? Okay. Is there any part of this I still need to simplify? Remember, what's the one thing I can never have in my final answer? A negative power. There we go. So what's the only one that's going to the denominator? Is it the 9, the a, or the b? The a. Okay. So this is going to be negative 9b to the 5th over a cubed. See, I only have to take the reciprocal if it's a negative power. Okay. And I think I may have just confused myself. Why is the negative on the 9 okay? Yeah, because that negative isn't on a power. It's on a coefficient. That's perfectly fine. We just can't have a negative power, a negative exponent. Okay. All right. How about try number 7? I've got 3n to the 7th divided by 6n cubed. Okay. Well, what can I do with 3 and 6? Yeah, what's a common factor? What divides both of them? 3 and 6. 3 will go into both. So 3 will go into itself once. It'll go into 6 twice. Okay. Let me use a different color here. Now I've got n to the 7th over n cubed. So I've got 7 n's on top, 3 n's below. How many n's and where would they be left? There we go. So 3 below cancel with 3 above and leave me 4. It's not letting me write very well today. So my final answer, the only thing I have left up top is 1 times n to the 4th, so n to the 4th, over 2. Is a lot of this familiar from algebra? Remember in the exponent rules? If not, that's okay. Okay. All right. What about number 8? This one is a power of a power. Remember, if a power is raised to a power, what do we do here? We multiply. Kind of think of this as a distributive property. but it's only a power times a power. So this would actually be a to the what? A to the fourth and b to the sixth. There you go. Okay, I think we're starting to get it. Okay. Well, take a look at the remaining ones. Are there any on there that you're looking at? You're like, I'm not really sure how I would do that one. Okay. 27? Okay. I think 27 is probably going to be a big popular one. Okay, let's take a look. So 27. All right. Now, again, the rules don't have to go in any particular order. I could go ahead and take the reciprocal, or I could go ahead and just use the quotient rule. I can subtract the powers as they are. Okay. Let's say I want to go ahead and use the reciprocal in this case. Up top, x squared, y cubed, z to the fourth. Are they happy? Meaning, do they want to move? How do we know? How do we know they're going to want to stay exactly where they are? Yeah, because the powers are already what? Positive. So they don't want to go anywhere. But what about x to the negative 3, y to the negative 4, z to the negative 5? They're not happy. They want to move. Where do they want to go? They want to go up top because they want their power to become positive. So look at it this way. You've got x squared waiting up top. The x to the negative 3 joins it. Now it's x cubed times y cubed. It's going to be joined by y to the positive 4. We've already got that z to the fourth, and it's going to be joined by what? Z to the fifth. Now remember, if everything leaves either a numerator or a denominator, we're just left with 1. But again, what happens if you divide by 1? It's the same. Nothing happens. Well, let's see here. What's x squared times x cubed? X to the fifth. Wait a minute. Why isn't it x to the sixth? There you go. If it's a power raised to a power, then you multiply. If you're multiplying terms with the same base, then you add those. So this is going to be y to the what? Y to the seventh and z to the ninth. Okay. Now, let me show you something really cool. Now you're like, Mr. West, you show us something cool every day so far. I don't know if I can handle it. Okay. So you remember you've got this rule here. Oh, I think I knocked something over. If you have a fraction that has the same base, this is where you're going to subtract the powers, right? So this would be a to the m minus n. It's always the upper minus the lower power. Everybody's okay with that? Okay. Well, let's actually say I want to go ahead and apply that for each pair of like bases that I have. Well, up top, you'll notice I got x squared, right? Let's just look at that by itself. X squared over x to the negative 3. Let's apply this rule. So this is going to be x to the power of 2 minus negative 3. What happens when you subtract a negative? It changes it to positive. It adds it. So this would be x to the 2 plus 3. There's our x to the fifth that we got originally. And you'll notice the same thing will work for the y's and the z's. Okay. Nice. Okay. Are there any other problems in that section you'd like to take a look at? Do 4? Okay. So let's take a look. So I've got 7m cubed times negative 3m to the negative 3. Okay. So we could multiply together. We could take the reciprocal. What do you folks want? Do you want to multiply? Okay. So what am I going to multiply the 7 by? Okay. So 7 times negative 3, that's going to give me a negative 21. Now I'm going to multiply m cubed times m to the negative 3. So we're multiplying with the same base, add, subtract, or multiply. We're going to add. So this is going to be m to the 3 plus negative 3. But what's 3 plus negative 3? And what's anything to the 0 power? 1. So this is really negative 21 times 1. So it's negative 21. Aaliyah, is that good? Is that what you got? Fantastic. Okay. All right. What else? Any other problem on there? You're like, I'm not sure I could get that. Yes. 15. Okay. 15. 15, 15. Okay. So it says 3x to the fourth over x to the negative 2 squared. Okay. Let me go ahead and get this out of the way. Well, the first thing I'm going to notice is that down in the denominator, we have a power of a power. Okay, so what does that mean? Add, subtract, or multiply? We're going to multiply. So right now, up top, that 3x to the fourth, it's staying exactly as it is. We're not doing anything. But x to the negative 2 squared, that would be x to the negative 4. Okay. Now, we've already seen both ways. I can either take the reciprocal for the bottom denominator, or I could apply this rule down here where we subtracted the powers, the quotient rule. Which one would you like? The quotient rule? Okay. Now, the 3 doesn't have a 3 down here, so it's just going to hang out and wait for the x's to take care of itself. So as far as the x's go, it's going to be x to the upper power minus the lower power. But again, we're subtracting a negative. That's going to go what? Positive. So what's my final answer? Okay. That's it. Okay. Good, man? Okay. Anything else? Number 16. Let's look at 16. Okay. So x to the 3 halves divided by x to the 1 half. So I would definitely go ahead and use the quotient rule on this one. Okay. Erase that again. Now, I always tend to forget because I'm older. Would this be 3 halves minus 1 half or 1 half minus 3 halves? Always the upper minus the lower. So it's going to be 3 halves minus 1 half. And this one was already really nice to us. We have a common denominator. So what's 3 halves minus 1 half? Okay, so we go ahead and keep that common denominator 2. 3 minus 1 will give me 2. But what's 2 halves? It's just 1. So just x to the first or just x? Yeah. Yes. And we're out of here. This is 4th period, so we're out of here. 50. Oh, yeah, we got time. There you go. Just type in your 1,000 number. There we go. What's up? Oh, yes, I had one. Looks like it got thrown out. Okay, let me grab another. I haven't even gotten us our language yet. I need a pen. Go. Okay, so this is 2204. P West. Okay, you're good to go. Okay, cool. Emma, is that good? Okay. Anything else? Anything else? These are good questions. Okay. So I'll tell you what, you folks have done an amazing job today. You paid attention. You've gone through. You've answered my questions. Let's go ahead and do example 1, and then we're done. We'll finish up for the day. Unless anybody wants to keep going. Keep going. Somebody said it. I don't know who it was. Sebastian, it wasn't you? Okay. Let's see. All right. Let me go ahead and erase this right here. Okay. So it says if 3 to the x plus 2 equals y, then what is the value of 3 to the x in terms of y? So here's what they want you to do. They want you to rewrite this equation so that it's just 3 to the x equals. That's what they're referring to. Everything to the other side, including y. Okay. Well, there's one very important idea about all of these rules that I've shown you today. Every single one of these rules is reversible. Okay. So what am I meaning when I refer to that? Well, let's see. We come on down here. Now, we've obviously got a portion of this where we're adding the powers. Okay. So let's say I have, a to the m plus n, what was the rule that got me here? How did I know that I was going to add those powers? Remember, we had to multiply terms with the same base. So this was a to the m times a to the n. Okay. So see, that's exactly what I can do with 3 to the x plus 2. All right. So let's see here. 3 to the x plus 2, what would that equal? Now, this equals y. I'll go ahead and work from both sides. So how would I get 3 to the power of x plus 2? What product would have given me that? Yeah, 3 to the x times 3 squared. See, is everybody okay with that? All I did was reverse that rule. Okay. Now, our goal is to get 3 to the x all by its lonesome. That's what I want to isolate. Well, what is 3 squared? 9. So I would have 3 to the x times 9 is equal to y. What's the last thing I got to do to get rid of that 9? What's the opposite of multiplication? Division. So what should 3 to the x power equal? Is it A, B, C, or D? There we go. So now we've looked and reviewed over the exponent rules, so that's what this whole section is over. The types of PSAT problems that are going to incorporate these. Okay. All right. So I just want to throw that out there. We can keep going. All right. I said we go ahead and stop. You folks did a great job. I appreciate it. We'll come in tomorrow. We'll finish up those notes. Okay. So here's the thing. Please hang on to these notes. That's why it's so important to have a binder or a folder, because I only make enough copies for this group and the group that I'm going to be getting from Mr. Schmidt in a couple of weeks. So please make sure that you hang on to these. Bring this packet back tomorrow. Okay. And then we've got ourselves, what, 5 minutes? Not a lot of time, but, for the first day, I think that works out. Let's go ahead and get those calculators back up front. And then I think we will be ready to go.